All right. Welcome, everyone, to the second session of the Space Syntax Lab seminar series. Today, I'd like to welcome Professor Akkelies van Ness. She will talk about measuring the degree of permeability of the main root network with angular step depth analyses, introducing a new method to measure permeability. And Aki is based at the Department of Civil Engineering at the University College Bergen. She served as a chairwoman of the 5th International Space Syntax Symposium in Delft in 2005, and last year at the 13th International Space Syntax Symposium in Bergen. Aki has led and participated in several international research projects related to mobility and network characteristics, and these projects range across a variety of topics such as revealing the relationships between space and energy use for transport, crime in neighborhoods, street life, urban centers, and economic development. They also cover applying space syntax in regenerating urban areas and developing theories on the relationship between urban space and urban sustainability. The core of Aki's research activities involves developing and applying various spatial analysis tools to build environments at various scales, and testing these against socioeconomic data and energy data, among others. And before we start, we will have a Q&A session at the end of Aki's talk. So if you have any questions during the talk, please put them in the chat so we can get to them at the very end. And with this, I'd like to hand over to Aki. The floor is yours.
Thank you. Hello, everyone. I say good morning, good afternoon, good evening, depending where you are in the world. So it's very nice that we can meet in this way. I see a lot of names, which I saw at the symposium in Bergen. So both online and physical. So I'm going to share my screen, and then you will see my PowerPoint, and I will open it, and I will start it now. And I hope you see my presentation.
Yes, excellent.
That's good. This is just a method which developed through research lasting for years. And then at the end, I did some sort of systematic testing to see, does it make any sense? And it is all based on research from others, and also to see it's just first identify the main router network. And the other thing is to measure how permeable are they to the vicinity. How well connected are the neighborhoods connected to the main routers? And one of the things I was still busy with, that was the keynote paper of Bill Hillier from 2007. He said that the city has a dual nature, and they say they have a foreground global network, which reflect the microeconomic pattern. You see it in every city, and they call it the general component of the city. And then you have a background local network, and that reproduce the culture pattern. And he showed also, when I was studying London in 2000, like how various local culture, they have different local radius measures. And that was particular after Kavan's PhD thesis, where we used the classical space syntax with the X map. And he showed that most European cities had a radius 3, and where Persian and Arab cities have a radius like 5. And then you see where the bazaar emerge. And this is all related to cultures, and Bill Hillier called it the conservative component of the city. And my question was like, okay, this foreground network, he used it as a sort of abstract term, is like, how do you identify it? And I remember also one presentation from Hillier. He said that the city consists of a very low number of long streets, and they're connected to other long streets with a shallow angle. And then you have a very high number of short streets, and they tend to end sort of 90 degrees to another street. And you see it in mostly every city. And this kind of long streets, it functions somehow, I call it the spatial armature of the built environment. And the question, how do we identify them? This is the first step. You need to identify them, otherwise you cannot measure the degree of permeability to the vicinity. So below I have sort of examples of main routes. The one you see is from Oslo and one from The Hague, and now it's Amsterdam, and then the other is from Stockholm. And you see that mostly tram lines or bus routes tend to run through this street, and then also I call it the main pedestrian street, this long linear one. High Street, Main Street, you name it, they tend to be a part of this, I call it spatial armatures, that is, how to say, putting the city together. And the one thing is like, because if you look at space syntax, it's a quite successful method because of its precisions, and also it has a very descriptive approach. And methods is very well developed and have also been tested in different cultures. It's also quite context independent, so you can apply it in all types of built environment. And these 4 principles, what I see in space syntax, I want to apply them really on how do we identify the main router network. So what method do we use? So to stick to these principles. And here is just showing some image, the classical actual map, pure direction change of Oslo. So you see like how it identified the global and here the local centers of Oslo. And you see a sort of contour that this kind of local shopping streets, and which is later they call it 2 movement potentials. But there's been some attempts to identify what you call the through movement potentials. And it all started with Stephen Reed's PhD thesis, which is finished in the middle of the 90s. And then he went to London, and then he applied what you call the integration gradient. That was with the all X-Men. And then he saw like there were some routes when he was counting pedestrians that some streets, the data were peaking up in comparison with the side streets. And then he started this kind of manual hand draw map. And I felt like the identification criteria didn't work very well. He presented the paper, what you call Flat City, at the 5th Space Syntax Symposium in Delft. And then was a question from one of the audience, how do we identify the main route? And he did not have a proper answer, just drove the most busy routes. And I felt like I was not happy with this answer. So, and then in 2005 also we had the first DepthmapX workshop with Alistair Turner, and I started to apply that. That's the year when I stepped over from the Axeman to the DepthmapX. And I started to play around because it could take the angular analysis, and it was just topological depth of mean depth. I was using mean depth and did some angular analysis with the topological radius, like with 3-direction change or 8-direction change. And I presented the paper in 2009 at the 7th Space Syntax Symposium. And then later, the angular choice analysis and what you call the 9 and a Nash, like the normalized angular integration and the normalized segment integration start to be with metrical radius. And that turned out to be more successful. So at that time, when I was starting to playing an experiment, I would just want to make an overview. If you look, here is a map of Amsterdam. The global actual integration. This is the whole province of North Holland, but you see on the global actual map, you see some tendency of where are the most integrated, where you see the tram lines of Amsterdam. But when you take a local angular integration with radius 3, you see the red lines, you see like where all the trams are running. So you see these are the routes with the highest through movement potential. And these routes is also like comply with the findings of Stephen Reed's PhD thesis. And then you have the 2 under is like what you call, this was the total depth with a low metrical radius of 800 meters, and the other was of 9 kilometers. So this was done in 2000, We were dealing 2008, 2009, the paper was published. But here is an old integration gradient analysis of Amsterdam, which I did in 2003 in the old depth map. And you see the white pattern of shops. It also indicates where's the true movement. And it was more, it shows some contours of this. But, and then based on that, we used to make hand drawings of it. And here you see a map of 2 areas of Amsterdam. So the one is on the left is what you call traditional neighborhoods, and then you see the main routes are running through each neighborhood. Where on the right side, it's when you come in the suburbs of Amsterdam, the main routes are running between the neighborhoods. So it has some sense. I didn't want to throw it away, but until then we did this kind of drawing by hand. And then you see like this deformed wheel pattern what Hillier talked about. You saw this kind of thing taking place in the cities when we identify and try to draw it by hand. So, and here is a map. What also I was very busy around 2003 was to make analysis of the whole Randstad in the Netherlands. So you see up here is Amsterdam, Leiden, The Hague, Delft, Rotterdam, and Utrecht is here. And here you have Gouda here, the small cities there. And this is just identified by hand. I was not happy with this map, so we made it by a workshop. And but then in 2005, in 2004, 2005, we were doing a study on space and crime in 2 Dutch cities, Alkmaar and Gouda. And we realized the main route in that we register everything. We walk through the street, we take all kind of methods we can do and register everything to see it makes sense. And this was like the total depth analysis. And from there you see a contour of a main route. And of course, when you have the angular choice with the metrical radius, you see a much better contour on these main routes. And here is Gouda, the old angular analysis. In fact, it's the total depth analysis. And here you see the angular choice analysis, far better results. But we were fiddling with that. But anyway, we identified the main routes, and then first we did was to take the n steps analysis. It's like you count every direction change. It's independent on the angle of the route, and then we plotted up with Berkeley data, and then we saw the further you are away from the main routes, the more houses were intruded by the front door. And the more closer you are to the main routes, they are entered from the backside through the back garden. So that is what we use to identify them. And the interesting is that we have several variables. We did the microscale tools, how entrances are located to the street, if the street is constituted, and whatever. But the really dependent variable was the main routes. So we felt that we cannot give it up. I felt like I cannot give it up. And so I was busy with that in 2008, and this paper was published in 2009. And I always like to apply on the Dutch town Leiden because it has very curved street. And that has also to do with an angular analysis. I was never satisfied with the results from the traditional space syntax. So this became always my test case on everything I did. And then I tried to identify to do the what you call a total depth, and I added 2 on top on each other. Quite simple, but still I was not satisfied. So, and while I was fiddling with that, in 2005, Hillier and Ida presented some sort of new method of this kind of choice, and it's been developing throughout the years. And since 2012, they become quite settled, and that is the angular choice analysis with the metrical radiuses, where you include the segment length and also the angular segment integration analysis with the high and low radius. And the angular choice is often called the through movement potentials, and angular segment integration as two movement potential. But here in my case, I was very interested in the through movement potential because that has something to do with the main routers. And here are sums for the mathematicians. So I was really interested in this kind of angular choice, what you look at. And as you see with space syntax, they're very concerned about how does each segment relate to all other. Here you have like 5 different method that has been most used and settled. But and the other thing is like the segment map. There are different ways of doing to calculate, and if you look at the part C and D, is like, do you use the road center line, or do you use, you know, where DepthmapX breaks up the actual map into a segment map? So, so this is always a discussion. In my case, it's always like if you look at the angular segment step depth, how they're calculated, when things have a shallow angle of deviation, the value become very low. And if you have a sharp angle of away from this segment, which is called mark with the number 0 on that one, this is a sort what you call an angular step depth analysis from this segment, and you start on 0. And if you have no angular deviation, this is of course also 0. And then you can see a contour of a main router. So this is, and here I show you, like, if, as I mentioned, like these long streets that are connected to other long street, they have a very small angle of deviation. If you travel from segment A to B to C, but if you travel from A to D, you have a quite sharp angular deviation. And then you see this kind of new way of presenting it in a G-graph. So it means like the main routers that tend to be very closely connected to one, where you have this kind of side streets that tend to be more, lesser connected in terms of angular step depth. And it has all to do with this kind of angular weighting, what is used in DepthMap. I remember that Nick Sheep Dalton, he made this software. Meander was a test version in around 2001, 2002, and had a different weighting. So, but this DepthMap, this is what is used. I'm going to skip this one. But anyway, when you look at accessibility based on angular weighting, if you look at the segment, this red segment, if you have a topological radius, like 2 times direction change, you reach everything in this strict orthogonal grid and quite limited of the twisted grid. A metrical radius, that's just pure metrical distance. But if you look at the geometrical radius, like the angular deviation from it, and if you are traveling, how to say, 180 degrees from that red segment, you can see that you reach further on the upper part of the irregular grid than the lower part. So, but anyway, what this angular choice turned out to be the most useful tool, the angular choice with the high metrical radius. Here, I will just to show you 2 towns in the Netherlands. I always like to use this Hilversum. It's from 1400. And here you see the red main routers, and they tend also to run through when you have a choice with a low metrical radius. And there you see the really city center, the pedestrian here. And then I like to compare Hilversum with Lelystad, which is a modern through planet town. The first people moved there in the 70s. And you see here with the high metrical radius, you see the main routers that are running between the neighborhoods, and then the low radius that are completely at a different place. And here in the middle, if you go back to the previous one, here is a big car-based shopping mall. So that is Lelystad. So when I was applying this kind of choice with the 2 metrical radius, I realized, like, also again, how are the main routers, how are they placed in relationship with local centers? They run right, they're quite well connected to the existing local centers in the traditional areas, what you see on the top. If you look at the below, if you look at the highway areas, you tend even to get the big car bay shopping malls where you have a biggest junction of these main routes, and then you have inside the neighborhood, if necessary, just the necessary food supermarket, like a store for the locals. So that is what you see. So first, what I say, like, okay, first identify the main route network. Use the what I really like when the segment length is incorporated into the choice calculation. Then it makes also possible to add the metrical radius, and you need to have the higher radius for identifying of the main routes, and then you have one bottom what you call angular step depth. You take it from the main routes, and then you see that is a way of measuring degree of permeability. So I will show this description. So first what you do is you run the choice with the high metrical radius, you open up the scatter plot. And then it's very important that you have on the x-axis and the y-axis the same value, so you get a linear. And then if you mark all the streets except the dark blue, you mark them. You have to keep it on choice, you know, like with either with radius n or with the high metrical radius. And then, of course, when you remove the scatter plot, then you see that all the routes are marked, selected. And then you have in DepthMap what you call the step depth button, and you click on that one. And then you go to the color range. And on the color range, you put the red here and the blue there in order to highlight, and then you click apply. And then when you do this, then you will see this red main route is really well marked. This is just to show visual. Yeah, it really shows like the red main routes, and then you see how permeable are they to the vicinity. So here is the historical city center of Annaba, is a city in Algeria. And then you see the main route is running out, this kind of deformed wheel moving out from the city center. And I want just to show some of maps which I did for cities around the world. I applied it on 25 cities to do more systematically and have a quite culture and geographical representation. And here's Auckland in Australia, and you see how the historical or the main center is quite well connected, but the rest you see how it is in the suburbs, quite car dependent. And then opposite you have Amsterdam. So here you see really the center of Amsterdam, and you see that the bus lines are well connected really to the vicinity. All the bus lines tend to follow this, and tram lines tend to follow these red routes. But as soon as you move into the suburbs, which you see here, and also which you see here, the accessibility to the vicinity is quite poor. And here we go to a city, the capital of Jordan, called Amman. And here it's very interesting to see. You see the main routes, but you see due to this culture pattern, Persian and Arab city tend to be more, how to say, tend to have more labyrinthly street network on the local scale than European cities. And you see it very clearly in this step-depth analysis. Here I show you Banda Aceh, and you see that if I can find the cursor here in this part, this is the colonial city center influenced by Dutch planning. And here in this area, you see around here, it's there you see more because it's a Muslim country, and you see that the culture to have a more labyrinthine street network comes in this part. Here is from Bangkok. It's also one spots. You see that some informal areas become very little accessible from the main route network. Barcelona is very interesting to see because it has a quite strict orthogonal street network, and then up on the hills, and then the historical center of it's not so well connected to the main router network. Here we have Bergen, where we had the Space Syntax Symposium. Here you see the old center of Bergen and some old neighborhoods. But as soon as you come on the hillside and newer areas, they're quite disconnected to the main router network. Berlin is like a typical most European city, like Vienna, quite relatively well connected to the main router network. Buenos Aires is very interesting to see because it has a quite patchwork of grids, but they are somehow not so, they're a little bit broken up. So that has an influence. And then I show you some of the Dutch from the Caribbean islands, from the Antillen, and it's the capital of is Curacao, and quite private car dependent. So except the city center, which is here. So you see, like, and here we have some interest. What about Manhattan? In New York, this is downtown Manhattan, and this is the whole Manhattan. And you see, like, interesting when you try to adjust the color, use the same, you get either blue or either red. But colors does not say anything because we want to look at the numbers. Here, of course, Oslo. And what's very interesting, inside the Ring Road 2, here you see that the three historical Oslo has three centers, and all three centers seems to be quite well connected, and the rest of the town, it's of the city, it's quite poorly connected to the main routers. Here you have Rome, just to have some, and Shenzhen. This map is 15 years old, probably outdated now. And here is the center of Shenzhen. And here's Venice. It's always interesting to show Venice. And you see the red route is where you see the largest flow of tourism. And here I show you one from South America called Valparaiso. And you see that the planet or the city centers here, and all the informal settlements that are located up on the hillside, you see that's quite poorly accessible from the city center. Now we're going to look more at numbers because all these fancy colors are not enough. So what I look here is for the whole city, and here's the city center, and this is one of the suburbs, and this is like the average step depth from the main route is based on angular step depth analysis. So the closer you come to zero, the better you perform. If you look at Barcelona, which has a strict orthogonal grid for the whole city, the average is 1.69. And also Buenos Aires, also, even though the map doesn't show. If you look at Manhattan, the downtown Manhattan, now this is the whole city Manhattan, it sees that 1.4, it's like one direction change from the main route. That is what it means. That's the permeability from the main route in Manhattan. And here we have Vienna, which is quite well integrated European city. If you look at the city center, remember Annaba, that's the town I showed you earlier. It is quite well connected. And also Barcelona, it's really, that is in a strict orthogonal grid, in the Sarda grid. And Kyoto is also quite well, even this is the city center. But if you look at the blue numbers, they are scoring very low because you have a lot of settlements on the hillside of Kyoto. But the city center is quite well integrated. And if you look at Vienna, it's also, you see the city center is extremely well integrated. But Valparaiso, that is quite poor. I think it's the lowest of everyone. And also African city, Kumasi, it's also quite poorly integrated city center. And here I choose like one of the suburbs of every city, and you see like Valparaiso, all the informal settlement, it has 6.64 like as a value angular step depth from the main routers. And you see also for the whole Venice, it scores also quite low. So these numbers is just showing how well integrated, how permeable is the main route is to the vicinity. So these are the 25 cities I've been testing it on, and it seems very clear that cities with a strict orthogonal street pattern, they tend to have very high level of permeability between the foreground and the background network, that we can say. And often informal settlements or segregated modern housing areas or with gated communities, these kind of neighborhoods contribute to poor levels of main route permeability. And also what I see in Arab cities and Persian cities that tend to have a lower degree of permeability between the foreground and the background network. That is also what I saw from the cases I use. And I say, okay, when you make something, what is the usefulness of this method? And it's a new way of quantify the relationship between the foreground and the background network of cities. And the next level where I'm now is just to test and apply it on this method, connected to various social economic data. And I hope that also this systematic empirical testing can contribute to create further operational spatial analysis tools for evaluating planning and urban design proposals, and also to make a diagnosis of spatial diagnosis of poorly functioning urban areas, and also for option testing in urban renewal project. So I used it also as a spatial diagnosis tool on the 40 worst neighborhoods in the Netherlands, and it seems also that poorly connected to the main route was one of the things I saw on this. I presented this paper like at the conferences, and I got the best paper award of it, international. So that was a surprise because this method was just developed just for fun. And but the most driver was is to identify the main route, but the angular step depth, this correlation, it really means something. And that is where I'm now, because we did this space and crime research in Alkmaar, Gouda, and here everything that was before Google Street View. So we walked through 1,200 street segments, but all the data and the reference numbers are based on the all Axment, and now we want to connect it to this to the DepthmapX file I have, and making decoders, and then we have at least all the burglary dates and theft from cars, and see if it does it make sense. It's really detailed, and also to connect to the microscale tools which we develop also through this research project. It's like how many semi-private and public spaces is between doors and windows and so forth. And here are some hypotheses. What do we want to expect? Because we have this kind of manual draw map. So we expect to find probably the more building and the further away you are from the main routes, it means like the more the building's entrance are turned away from streets, and also less intervisibility between building entrances with windows, and the higher burglary risk, and the more monofunctional the functions are inside the building, the further away you are from the main route. And also the high number of semi-private spaces are between the public street and the private spaces inside the buildings. That is what we expect to find. So that was my presentation, and I hope you enjoy it.